So here's the Everlast Power Plasma 60, and we've got the ground cable workpiece. Wire goes through this little strand and clamps onto our steel table here. And we've got back here the torch, and that carries some wires through the big loop and into our gun right here. And as you can see, there's a switch here and the front nozzle right there. At the back of the machine, we've got the power cable that goes through the 3 wires through there, and there's a male plug connected to a female plug, and that extension cord goes into right here, our plug, just as you would see for a normal plug, but this is for 240 volts alternating current, so different plug style, much larger wires is used. And now back here we have our gas inlet, and this gas inlet, if you trace it, this tube goes into this water vapor filter, and then that filter has an outlet here, and this is the quick connect plug for the air compressor. Okay, and that hose traces back into our air compressor here, and as you can see, the yellow tube ends up with another quick connect here, as you can see. So you just quick connect that, and you quick connect. There we go. And there we have the gauge with the turn on, turn off. And the air compressor, of course, plugs into the standard 120 volt power. So connection wise, that's pretty much it. And there's an important point at the front of the Power Plasma 60, which is, okay, of course you got the fuse here. You want to make sure that fuse is not blown. You got the pilot arc, that's just one wire that comes into the torch and connects to a part of the nozzle, and the last one is control. So this control actually is represented by a diagram I'm going to show you right after. As you can see, this is right here on the machine, on the Power Plasma 60. It has 4 female pins, and those 4 female pins connect to these 4 female pins, and the orientation is ensured by that little slot you can see at the bottom of that, matching the little slot, or rather the little dimple that you see at the bottom there too, so that you can only fit this onto that one way because of that dimple, only that way. You can't do it like this, because then the slot would be to your right, and then the dimple is going to stop this metallic piece from coming in. Now, that said, why 4 pins? Well, actually you don't need 4 pins. Here's how it works. You've got the female on the Power Plasma 60, you get the male that I just showed you separately, and what happens is the left 2 pins and the right 2 pins are actually connected. And what happens is, when you switch on the gun here, the gun, because the wires go into the gun, the switch electrically conducts the left pair of pins to the right pair of pins. And this was all tested with the multimeter, so it was double checked. So when you turn on the switch, there is a connection between the left pair of pins and the right pair of pins, and then the electronics in the Power Plasma 60 senses that the switch has been turned on, and the pilot arc goes, and you get a burst of plasma. So how can you fit this in with a torch table, or make it generally more modular? That's the task here. How do we make the control more modular? And this is how you do it. As you can see, we have the female 4-pin plug on the machine, represented here. This is a side view, plastic machine, and then we have the male piece, which is right here, fitted like that. And as you can see, at the back of this male connector, there is the 2 pins on the left soldered together, and the 2 pins on the right soldered together. Or rather, it's this orientation. So on the left and on the right, it's soldered together. So all you would need to do really is to solder one wire to the left pair of pins and solder another wire to the right pair of pins, and of course shrink tube the connection, the solder connection, so that you don't get any stray connections happening other than when you want it to. And then, as you can see, shrink tube those connections between the male pin and the wires. And you can keep these wires short, and I'll explain why later on. Example, 12 inches or 30 centimeters, depending on imperial metric. It's about the same. Very, very large tolerance. Okay, so after the wires comes, here's the good part. You have insulated screw terminals, and that allows you to be very, very versatile with what connection you do. So if you have, say, this gun, and at the end of the cased wire that you have for this is this connector, of course, but you can actually not use this connector at all and just use the two wires that are going to be coming out of here and screw them into the screw terminal. And if you do that, now you have a functioning plasma cutter with the gun, with the switch enabled. But if you, instead of using the wires from the gun, you attach the wires from, say, microcontroller controlled relay, solid state relay, then you can activate the control, hence turning on the plasma torch without pressing this trigger, and instead letting the microcontroller turn on the switch based on its programming. And let me just quickly show you what I mean by that screw terminal. So it would very much be like this, except instead of 3 pairs of terminals, it'd be only 2. Mount the connector, snip excess, flux it. Cut shrink tube, strip and solder wires, heat gun shrink tube. Alrighty, we've got the new modular connector clamped right here for the purpose of testing. I'm going to use this little insulated copper wire, and what I'm going to do is, you see those 2 red wires, I'm just going to turn the switch on, quote unquote, by just inserting these 2 wires into those 2 terminals, and then this plasma cutter should activate. Let's do it. Turn it on. Success!